Hello and welcome to Kashmatics. In this video I'll show you how to recognize a linear sequence and then how to find the nth term rule for the sequence. I'll then flip the questions around so you can find a sequence when you're given the rule instead. So grab yourself a pen and some paper and let's get started. First of all, let's define what a linear sequence is. A linear sequence is one in which there's a common difference from one term to the next. So if we look at this first sequence here, 2, 7, 12, 17, 22, we're always adding 5 to get to the next term. In the second sequence, we're always subtracting 3 to get to the next term. So because there's a common difference between one term and the next, these are called linear sequences. On the right, we have two other sequences, but they are not linear sequences. So even though we're multiplying by 2 to get from one term to the next over here, the number we're adding is actually different each time. Here we're adding 3, then we're adding 6, then we're adding 12, then we're adding 24. Okay, on the second one, we're dividing by 3 to get from one term to the next, but we're not subtracting the same number each time. So for example, to get from here to here, we'd take away 18, then we take away 6, and then we take away 2. Okay, so because the difference isn't common each time, these are not linear sequences. So now we know what a linear sequence is, let's go on to one other thing we need to know before we do the examples, and that is how to use algebraic notation for a times table. So if I want to express the 3 times table, I just say that's 3n. If I want to express the 7 times table, that would be 7n. The minus 4 times table, so minus 4, minus 8, minus 12, etc., that would be minus 4n. And even a decimal timetable, so 1.53, 4.56, 7.5, that would be the 1.5 times table, so that would be 1.5n. And with any other timetable, if it's a 10 times table, it'd be 10n, 12 times table would be 12n, etc., etc. And the reason why this rule works is because I can get to any number in the times table by multiplying 3, for example, by the number in the times table I'm after. So if I'm after the 15th number in the times table, I do 3 times 15, which would be 45. If I wanted the 20th number in the times table, I would do 3 times 20, which is 60. So this algebraic notation helps us to get to any number in the times table that we're after. So here I've got 3 examples, and I'm going to show you how to work out the nth term rule for each of these. So the first thing we need to do is work out what the sequence is going up in. Okay, so we need to work out what we're adding or subtracting each time. And in this case, we're adding 7 each time. To get from one term to the next, we're adding 7. And what we do next is we make ourselves a little table. So I'm going to write POS for position number. Okay, so position number 1, 2, 3, 4, 5. So I've got 1, 2, 3, 4, 5, and n. Okay, so position number n. Then you write down the sequence. Okay, and I'm going to leave a bit of space in between. And the sequence that we've got is 8, 15, 22, 29, and 36. And in between that, what I do is I write the times table of whatever is going up in. Okay, so in this case, it's going up in 7s, so I'm going to write down the 7 times table. So 7, 14, 21, 28, and 35. And then I go back to what I was talking about in the last slide. Okay, to express the 7 times table, we just say that is 7n. Okay, so this row here is called 7n. Okay, so if the top row is n, to get to this row here, we just multiply it by 7. So this row is 7n, so that's my 7 times table. And then I look to see, how do I get from this row to this row? Okay, it's always going to be add something or subtract something. So as you can see, with each of these numbers, all I need to do is add 1. So if that middle row is 7n, this bottom row is 7n plus 1. So my nth term rule, so we can write nth term is equal to 7n plus 1. Now sometimes people will write the notation like this, so they'll write Tn equals 7n plus 1. So just be prepared to see that and make sure you understand it if you do see it. Anyway, the reason why this is so powerful is because I can now work out any term I like in that sequence. It's always easy to work out the next term, you just keep adding 7. Okay, so you add 7, then 7 again, then 7 again. But if I wanted to go straight to the 30th term, okay, so this is meant to say 30th, not 36. So all I need to do then is do 7 times 30 plus 1. So n is the term number, so 7 times 30 plus 1. So remember, this is 7n plus 1. So 7 times 30 is 210, plus 1 is 211. So let's look at the second example. We can see it's going up in 8. Okay, so we're adding 8 each time. So it's something to do with that 8 times table. So let's just make our table. So position number 1, 2, 3, 4, and 5, and then n, and the sequence is 1, 9, 17, 25, and 33. And in the middle there, we need to write down an 8 times table, which is 8, 16, 24, 32, and 40. All right, so this row here is 8n. I need to see how to get from this row to this row here. So remember, you always go from your times table to your sequence, not the other way around. So hopefully you can see we need to take away 7. So it's 8n take away 7. So the nth term rule is equal to 8n take away 7. And if, for example, I wanted to work out the 20th term, I can do 8 times 20, take away 7. And 8 times 20 is 160, take away 7 is 153. And the last example, this one here we can see is going down in 4s. Okay, so we need to be a bit more careful here. So it's going down in 4s, so it's going to have something to do with my minus 4 times table. So let's write down our position number, 1, 2, 3, 4, 5, and n, and then the sequence, so 15, 11, 7, 3, and minus 1, and then the minus 4 times table, so it's just like the 4 times table with a negative sign in front of it. Okay, and there's my minus 4 times table, so this is minus 4n. Then I look to see how I get from the times table to our sequence. So I've got minus 4 and I've got 15 here. So I need to add on 19. Okay, and if you can't see it straight away, just try it with some numbers which are a little bit easier to see it with. So it might be easy for you to see it with these ones here. But please remember to go the right way. Okay, we're adding on 19, we're not taking away 19. So this would be minus 4n add 19. So my nth term is minus 4n add 19. Now it's actually neater to write it as 19 take away 4n, but it's entirely up to you which way around you write it. And just like before, if I wanted to work out any term, I just replace n with the term number I'm after. So if I wanted to work out the 10th term, for example, I would do 19 take away 4 times 10, or over here I could do minus 4 times 10 add 19. Either way, I'd get the same answer. And now it's your turn to try. Okay, what I want you to do is find the nth term rule for each of these sequences and then the term indicated in brackets. So for example, in the first one, you work out the nth term rule for that sequence and then work out what the 20th term of that sequence is. So pause the video and I'll put up the answers in a little while. And the answers are going up in 3, 2, 1, and there you go. Okay, so just check your answers, see how you did, and then we can move on. Now, what we're going to do next is work out the sequence from the rule. And what I want to do is write down the first 5 terms of the sequence with the rule 7n minus 3. So if you think about this, the 7n part tells us which times table it has something to do with. So we know this sequence has got something to do with our 7 times table. And the minus 3 tells us every number is 3 less than the numbers in the 7 times table. So the first number in the 7 times table is 7. But we're going to have 7n take away 3, so the first number is going to be 7 take away 3, which is 4. Okay, so 4 is 3 less than the first number in the 7 times table. And from then onwards, all I need to do is just keep adding on 7, because I know it's going to go up in 7s. So it's going to be 4, 11, 18, 25, 32, etc., etc. Now that's not the only way to do this. What you could do is just work out the first term by replacing n with 1, then the second term by replacing n with 2, the third term by replacing n with 3, but that just takes a little bit longer. But if you're more comfortable doing it that way, then just do it that way. And I'll just do a couple more examples just to hammer the point home. So let's say we had 4n plus 10, for example. Okay, so we know this sequence goes up in 4s, but the first number is going to be 10 more than the first number in my 4 times table. Okay, so the 4n tells me it's got something to do with my 4 times table, and the plus 10 tells me every number is going to be 10 more than the numbers in my 4 times table. So the first number in the 4 times table is 4, so our first number is going to be 14. Okay, that's 10 more than the first number in the 4 times table. So from then onwards, I just keep adding 4, so it's going to be 14, 18, 22, 26, 30, and so on. Now, if instead I had something like minus 3n plus 1, okay, this has got something to do with my minus 3 times table. Okay, and the sequence is going to go down in threes. So the first number in my minus 3 times table is minus 3. I need to add 1 onto that to get minus 2. Okay, now always extra careful when I'm dealing with negative numbers. And all I need to do now is go down in threes. Okay, so I'm starting with minus 2, minus 5, minus 8, minus 11, minus 14, and so on. And here's some for you to try. I want you to work out the first 5 terms of each of the following sequences. It starts with some nice easy ones and then it gets onto some slightly trickier ones, but the process is exactly the same as I've just shown you. So pause the video and give them a go, and then I'll put up the answers in a little while. So the answers are going up in 3, 2, 1, and there you go. Okay, so those are your sequences. So check to see if you got those right, and then we'll move on to some more problems. To finish with, here's 2 more problems. If you want to give these a go, then please pause the video. Otherwise, keep watching and I'll tell you how they're done. Right, so question number 1. If you want to work out whether a number is in a sequence, all you do is equate the number to that sequence's rule. So 4n minus 9 equals 131. And what you do next is just solve that equation. And if you solve the equation and it happens to be a whole number, that means it is in the sequence, and what it'll tell you is which number in the sequence it is. If it doesn't happen to be a whole number, then that means it's not in the sequence. So let's just try and solve this. So 4n take away 9 equals 131. So let's add 9 to both sides to get 4n equals 140. Then if I divide by 4, I get n equals 35. So what we can say is, yes, 131 is in that sequence and it's the 35th number. Now when it comes to this other one, let's do the same thing. We've got 4n minus 9 equals 270. So 4n would equal 279. And, well, 279 is an odd number, and I can't divide an odd number by 4 without leaving any remainders or having a decimal. So if I did that, I'd get n equals 69.75. Okay, so we can see for this to be in the sequence, it would have to be the 69.75th number, and that doesn't make any sense. So 270 is not in that sequence. Now this second question is slightly trickier, and what we need to do is use simultaneous equations to actually solve it. Now that's not the only way to do it, but it's the way I'm going to do it. Now the first thing I'm going to do before I do anything is to just generalize the rule for the sequence. So we know it's going to be something n plus or minus something else. Okay, I'm just going to write it as an plus b. So we know the 23rd term is 196. Okay, so 196 is going to equal a times n. So in our case, n is 23. So this becomes 23a plus b. Okay, so that's what I get when I plug in n equals 23 into this. Okay, so a times 23 is 23a. So that's where that comes from. Now I can do the same thing for the other term. So we know that 412 is equal to a times 47, so it's the 47th term, so 47a plus b. Okay, so this is equation 1 and this is equation 2. So if I do equation 2 take away equation 1, I need to do 412 take away 196, and that gives me 216, equals 47a take away 23a, which is 24a, and b take away b cancel each other out. And if I divide by 24, I end up with a is equal to 9. Okay, so I know a equals 9. Now if I substitute that back into equation 1, I get 196 is equal to 23 times 9 plus b. So I get 196 is equal to 207 plus b. And if I subtract 207 from both sides, just need to be careful here, I get minus 11 equals b. All right. Now that means my nth term rule is equal to, remember it's an plus b, so 9n plus b. Now in this case b is minus 11, so it's 9n minus 11. So if I want to work out what my 10th term is, I do 9 times 10 take away 11. Now 9 times 10 is 90, 90 take away 11 is 79. So my 10th term is 79. And that's it for linear sequences. I am intending on doing another video for quadratic sequences, but for now, thank you for watching and listening, and I hope you'll be back for another tutorial. Goodbye for now.